Okay, we're still talking about advanced internal ballistics in this video series. We just got done covering in detail bore condition and bore wear. We talked about all the different bore erosion mechanisms, and I thought that before we get started on this next one, we're going to be talking about coppering and propellant residues and things like that on this video. And then after this, we're going to get into the bore cleaning maintenance regime that we're going to establish for precision rifles. But I kind of want to remind us all of exactly where we're at in this video, because it might be kind of confusing. We've been talking about a lot of stuff, and what's the point to all this? This whole part of the series about bore condition and bore wear, and even the rifle dynamics, we talked about how the barrel and stock contact points can throw off your harmonics. The stock warp can throw off your harmonics. We talked about all these solutions for correcting vibratory inconsistencies. And the vibratory inconsistencies we've been talking about in the last videos are due to bore and projectile dynamics. We have inconsistencies when the bore condition and the amount of erosion changes over time. That's going to change the vibration nature of your rifle as the bullet exits the muzzle. And what can happen is you can have bore axis shifts. So that's what we're talking about. And this whole part of the series here is bore axis shifts due to harmonic and vibratory inconsistencies, which can cause inconsistent whip action, which is going to cause your bore axis to be pointing in a different direction as the bullet exits the muzzle. So all these different things are going to cause differences in how your rifle vibrates, and that's why, like we said before, when you shoot a 5-shot group, they're not all going to be exactly in the same hole. Sometimes, if you're lucky, you might have a real good setup, and it will. But that's the reason for round dispersion, is because all these different tiny things are going to add up and change your harmonics enough, and all these different vibrations going on are going to cause your axis of your bore to be pointed in different directions, and that's going to add to all the external ballistics things that we're going to be experiencing in the future here as well. So I thought I'd just qualify that so everyone knows kind of what page we're on, what chapter we're in, I guess. So this is just talking about advanced internal ballistics and the relationships that are going to change your bore axis shifts here. The next part of internal ballistics after all this is going to be talking about muzzle velocity variations, and that's going to be very, very important. But this first one's kind of complicated because there's a lot going on when we're talking about harmonics. And the solution to all this is going to be consistency. Trying to get everything as consistent as possible, whether it be your actual rifle system, your ammunition that you're going to put together, with our reloading that we're going to do here pretty soon, or if we're talking about these bore-projectile relationships. And that's what this video is going to be about. We want to keep our bore and its frictional relationships with the projectile as consistent as we can. That's going to be the fix to all this stuff. That whole last part of the series about bore erosion mechanisms is talking about how the bore basically is going to change over time. And that's something that you have to be aware of. If you zero your rifle when you first get it, and you get all your charts set up for a particular muzzle velocity and perfectly zeroed, it's going to change over time because your bore is actually going to change dimensions as you fire more rounds. So that's one major thing that we need to be aware of, and we're going to have to get ahead of that, and we're going to have to be able to predict where we're going to correct for that. Like, for example, you buy a brand new rifle, and you get it perfectly zeroed, and then, 1,000 rounds later, it's going to be hitting in a different spot due to these bore axis shifts. And the bore axis shift is going to be due to a difference in the friction dynamics inside your rifle bore between your rifle bullet and your bore. So that's gonna change how your rifle wiggles, and that's gonna throw you off. So we're gonna have to figure out a way to minimize that effect and keep on top of it. So that's what we're talking about in this video series here. So if there's one thing you can take home from this whole entire advanced internal ballistics part of the series, that is basically the idea that you're not going to be able to just get a drop chart for your long-range shooting, and that's going to work for all time. As you can see, there's numerous things that are going to change the point of impact due to these bore axis shifts, and it's also going to change our muzzle velocity. So just a simple one-page chart like matched to one specific ammunition, for example, is not going to cut it. That will work for the exact conditions in which that chart was developed. But you have any change in your bore dimensions due to erosion or any of these other mechanisms we're going to discuss here very soon, and you're going to have to get some different ballistic drop data for those changed conditions. So hopefully that's what you get out of this, that you're not going to be able to get away with just one nice simple chart. We're going to have to develop a different system for being able to keep on top of all these things. And when we get to, as soon as we're done with this ballistics portion of the series, we're going to finish up internal ballistics here, and then we're going to move on to intermediate ballistics and advanced external ballistics. As soon as we're done explaining those things, you will understand exactly why we're going to set up the charts the way we do. And it's really impossible to be able to use the charts that we're going to develop, the ballistic tables that we're going to develop, if you don't understand some of the basic concepts going on here. So just keep that in mind as we're going. I know a lot of you guys are really enjoying the series on ballistics, and you find it very interesting. And some of you are kind of possibly wondering why we're going so far into depth into this topic when other people don't go into that much depth. And that's the reason why. If you want to hit really tiny targets at extreme range, you're going to have to understand exactly what's going on inside your rifle and how to counteract that and correct for it. So this next video we're doing here right now is we just discussed bore wear and the bore erosion mechanisms over the last few videos, and we did talk about molly coating. But now we're going to talk about, and we're going to go quicker on this because I think the bore erosion was kind of a big one. But coppering, we're going to talk about that, and propellant residue, and then barrel conditioning are going to be a little more simple, basically. And we'll go a little bit faster through these. And then after we understand this, I will do a video on long-range rifle cleaning regime. We hinted at that in the last few videos that, for our long-range shooting applications, we're going to have to develop a different bore maintenance regime than you might have been taught for, other purposes. If you've been in the armed services, you use a battle rifle, M16, M4. If you're cleaning your M60 or M240 or whatever, you're not going to clean that the same way you're going to clean your precision rifle for the reasons that we're going to discuss here. So let's just get into it now here. Coppering. Coppering is another thing you have to be aware of when you're doing your long-range shooting, because this is going to change the friction dynamics between your bore and your projectile from shot to shot, really it will. And we're going to have to be able to figure out the coppering trend that takes place inside your bore. When you start off with a brand new rifle and you start to shoot it, you're going to have just a nice steel bore. You're rifling, and then you're going to have that copper jacket. You're going to shoot that. It's going to be going, and we talked about the incredible heat that develops inside there. And you're going to have a lot of friction, particularly during the engraving process, when your bullet starts to move into the rifling and it starts to have to kind of conform to the rifling shape. It's going to engrave to there, and that's a lot of friction. You're going to have, obviously, some of that copper rub off on your bore as it rams through that barrel. So coppering is real simple. Basically, as you fire your projectile, the heat and friction cause a thin film of copper to deposit in the bore. And, when you get a brand new rifle, you're going to start shooting it, and you're going to deposit a film of copper, and then you're going to take the next shot, and it's going to deposit some more copper, and you take the next shot, and it's just going to keep adding on to that amount of copper until you reach an equilibrium point. There's going to be a certain stage at which you have a lot of your coppers rubbed off, and when your next projectile comes, it's going to push out the same amount of copper that it kind of deposited. So that's the equilibrium point. And there's never really a true equilibrium if you really measure it out, but there is a point after a certain number of rounds is fired where basically your new bullet's going to swipe out the bore and clean it for you, and it's not going to get like a significantly higher amount of copper deposited from shot to shot after that point. And that's going to be something that we're going to want to be aware of. Where is that point? Because that's where we kind of want to be in terms of keeping our friction dynamics as consistent as possible. And this is where, when we get into our rifle cleaning regime, if you don't understand the reasons why we're doing it, there's going to be a lot of people who are going to question what you're doing, and they might argue with you. And you're going to probably want to be able to explain to them the reasons why you clean your precision rifle the way you do, okay? So that's why we're going into this. So keep that in mind. There is a certain point as you're building up copper in your bore to where it'll kind of level off. And it will continue to build slowly over time. You also still have these erosion mechanisms we talked about earlier taking place as, all these things are happening simultaneously. So it's not like a real simple deal. So things do change anyways. But there is basically a certain point where it kind of levels off. And that's kind of the point you want to be. Now, another thing to take note of is that the higher velocity you're going with your muzzle velocity on your bullet, the more coppering you're going to have. So if you've got a real hot cartridge like one of the Ultra Mags that's loaded real fast, you're going to have significantly more copper deposited for obvious reasons. You have more heat and more friction and more speed. So you're going to have more copper rub off with the higher rounds. So this is going to be a little worse on some of your magnums. And if you got a more mild round, like maybe a 308 or some of those that are a pretty efficient mild round, you're not going to have as much of the coppering issues as you would on some of these other ones. Because, the greater heat you have, the easier it is for that stuff to kind of rub off and get stuck into the steel rifling there. So that's one thing to be aware of. And we'll talk about this more when we discuss reloading and how to basically construct effective long-range ammunition. We're going to do a video on that pretty shortly too here. And I'll discuss the advantages and disadvantages to kind of loading real hot or loading kind of mild. And if you're curious, and I can give you a clue, I do like to load mild because all the advantages you would have to a hot load are basically outweighed the second you start scientifically correcting for all your drop. A flat shooting round is kind of the motive a lot of guys have to loading real hot ammunition because it kind of gives them some forgiveness in terms of like, okay, I'm not going to miss over the top or low as much if I miscalculate the range. That's what's good about a flat shooting round. But if we're doing our part right and we're doing our math right, you're going to be adjusting very precisely for the exact firing solution. And a bullet that's going 200 feet a second slower even is not going to really be that much of a disadvantage because you're going to be precisely correcting for that. So that's just a hint. We're going to get more into that later. Another thing about coppering we can talk about here is that if you just have a slight amount of coppering, basically what the general trend is the more copper gets deposited, the tighter your bore gets. And the tighter your bore gets, the greater pressure we're going to have in our pressure curve. And that's going to result in higher velocity. So as coppering increases, you're generally going to have an increase in muzzle velocity. And this is going to vary tremendously depending on exactly what kind of rifling you have, what your twist is, your caliber, your bullet, the temperature range that you're shooting, the frequency of fire. All these things are going to totally change how much copper gets deposited in the bore and how much that's going to affect your muzzle velocity. So there's no chart I can really give you that's going to kind of tell you, okay, after 40 rounds in a 308, you're going to, increase by so many feet per second. That's not really possible because those things vary so much on every little different input variable. So, but we are going to have to be aware of the general concepts. As you get more copper, your muzzle velocity is going to increase. And also, after you get to a certain point, like we talked about, we'll reach an equilibrium point where you stop really adding massive amounts of copper and it kind of drops up. And if you graphed it out, it would kind of level off there. You'd have a huge deposition at first, and then it would just real slow down, and it would almost plateau there. But after a certain point, if you do have excessive coppering, especially if you have real hot loads, like if you're shooting a 7mm Ultra Mag with kind of light bullets all the time, you're going to have excessive coppering. And that can result in, once you have way too much coppering in your bore, you can have erratic muzzle velocities. And that can be kind of really problematic for long-range shooting for a number of reasons. Not only is it going to change your velocity, which is totally going to change your drop and all that stuff ballistically, but it's going to change your point of impact due to these bore axis shifts, because obviously you got a different velocity. That's because all your different friction dynamics have changed so much. And the reason it becomes erratic when there's a lot of excessive coppering is because from shot to shot, once you have way too much copper, you're going to be taking out, it's going to swipe out some copper from one shot and add it into a different spot. And each time you take a shot, the distribution of that copper is going to be different within that bore after a certain point. So once you get too much, it does become a problem. And that's what we need to be aware of. Where is that point to where you have excessive coppering? And how do we figure that out? And that's something you need to know for our long-range precision rifle cleaning regime that we're going to develop on the next video here. So keep that in mind. And we'll discuss that on the video on cleaning, how to determine where that point is, okay? Another thing that we're going to talk about is powder falling, or propellant residue. Basically, obviously, we talked about the chemical bore erosion mechanisms because, you have these different recipes of gunpowder, and, some of the stuff in that gunpowder is kind of corrosive. We talked about carbon monoxide, carbon dioxide, oxygen, all these other things, and nitrogen is kind of helpful, actually. If you missed that, go check out our video on chemical bore erosion mechanisms. But in a nutshell here, our propellant residue is also going to change the frictional dynamics of the bore, because if you have a bunch of gunpowder residue, each time you shoot, it's going to be distributed a little bit differently within there, and what you're going to have is that's going to change your friction, which can also change your axis of your bore due to harmonic, inconsistencies. So if you read any of your gun maintenance manuals, like your field manuals that you use, or if you're in field artillery and you're reading the 640 manual or any of these where it talks about your propellant residue problems, they're going to talk about how residue, increased propellant residue is going to accelerate bore wear by basically chemical erosion. It's gonna cause like corrosion, and it's going to cause basically an augmenting of the abrasive action of the projectile. So it's kind of like a little sandpaper residue going on inside there. So it can accelerate bore wear. And one thing we have to take into consideration here, though, is that most of the literature we're going to find talking about bore wear, and even most of the new literature is going to be citing the old literature about propellant residue, gunpowder fouling. And the old literature is based on old chemistry, which is the original powder recipes, particularly even when I'm talking about propellant residue, that includes your primer chemistry as well. That's not just the propellant, but the primers specifically back in the old days, like, up until World War II and even after World War II, were quite corrosive, and mercury fulminate-based primers. And if you would leave your bore dirty over a certain period of time, that would cause extreme corrosion problems, and it was really, really nasty on steel. And you would get pitting in the bore, you get all kinds of rust in there from not cleaning your weapon. So that's why these cleaning regimes have been developed, by the military and even by civilians, is because the chemistry in the old days, especially if you go all the way back to black powder, and even the corrosive primers being used all the way up in the whole first half of the 20th century, you did have problems in rifle bores due to corrosion because of propellant sitting in the bore after firing. And that's where most of the cleaning ideas have come from, and the philosophy and how to clean a rifle. And so when you're reading a modern gun magazine, even, these guys are going to, and even the advertisements for the different gunpowder cleaning solvents and some of these things, they're kind of operating from the mindset that these powders still have the corrosive forces that they had back in the old days. And we hinted at this a little bit too in chemical erosion video, but the modern powders that have come out, since in our generation, are way, way, way cleaner than they used to be. And actually, some of these powders are developed to have a lot of nitrogen in them, and that can actually cause to preserve and protect the bore, sometimes more than it would if it was just sitting there completely clean. So it actually acts as nitriding your bore in some cases, some of these gunpowder recipes. So modern smokeless gunpowder, like post-World War II, post-Korean War, unless you're shooting really old nasty ammo, modern smokeless powder is very, very clean, and it's not going to cause any of these bore corrosion issues that most of these gun cleaning regimes had been established on. So that's something you have to keep in mind here. And a guy might be asking, well, just to be safe, we should go ahead and clean it the same way we would anyways, just to be safe. And I would say for most shooting purposes, that's highly recommended. If you got a carbine or a rifle, a medium range rifle, or even a deer hunting rifle, and you go out and you shoot it, I would strongly recommend doing a full bore cleaning like you would normally. However, as you're starting to get the idea in these long-range internal ballistics videos, any small change in any of these bore to projectile relationships in the friction dynamics, any tiny change is going to come significantly throw off not only your axis of your bore in your point of impact just due to that, but it's also going to change. We're going to find out after we get into the muzzle velocity portion of internal ballistics. It's going to throw off your velocity significantly. And every time you go through your rifle and start to clean it, you're totally changing the inside dimensions of the bore on a microscopic level, which is going to significantly throw off your friction that you had. So you might have been to a point of equilibrium, for example, with coppering and with propellant residue, to where from shot to shot you had a very consistent level of both coppering and of propellant residue. And then you go and you introduce your cleaning equipment and your solvents, and you remove all that. And not only do you remove the coppering and the propellant residue, but also you're going to have the entire white layer that we talked about in the chemical erosion video, that whole chemically affected zone that's very brittle. Anytime you start cleaning that out, you're going to remove that entire layer. Then you're going to have that thermally affected zone. You're going to have cracks in there. You're going to completely change the internal surfaces of your bore. And that's actually going to throw you off tremendously. And a lot of times when guys are talking about cold bore shots and how difficult they are, I think they're misidentifying the problem in some ways, because a lot of that has to do with your bore being freshly cleaned, being deployed in the field with a brand new bright and shiny bore that you just cleaned it, and the weapon was zeroed for a bore that was properly seasoned with coppering and was at an equilibrium point with this propellant residue. And so you were grouping well at that equilibrium point, and then you got all done and you had everything confirmed. Your zeros were confirmed. You take the rifle home, you clean it, and you completely change the frictional dynamics. And so it shouldn't really be a surprise to us after studying this topic that would significantly throw off your point of impact. Not only due to bore access changes, because the harmonics are going to change when you change the friction, but your muzzle velocity is going to be totally different too now. So that's kind of what we're getting at here in this internal ballistics part of the video, is you want to keep your rifle bore as consistent as possible. And the only times we should be cleaning our bore is if it's necessary. And we're going to tell you how to determine when it's necessary on the bore cleaning videos coming up next. But just to kind of recap those two things, the coppering, you have microscopic pits inside the bore like we discussed earlier. You will get copper in those, and that will augment differential expansion, because copper is going to expand with heat differently than steel will. And so that'll kind of assist with some of the microscopic thermal erosion mechanisms and mechanical erosion mechanisms, but it's not going to be, you got to kind of weigh the two things against each other. Which is going to cause more problems for us in our long-range precision rifle? If you introduce a wire brush to your bore with solvents in there, you're going to remove a lot more material than just the copper and the propellant residue. There's going to be that, like we talked about, that chemically and thermally affected zone. So you are going to remove steel from your barrel when you're cleaning as well. You're not going to see it because it's on the microscopic level, but it's going to actually remove more in most cases than your normal coppering issues would have. So basically, just normal coppering is going to remove less material from your bore and alter your bore less than trying to clean the copper out of it would have. Now, there is that point where we talked about excessive coppering, particularly in hot loads, where it does become problematic, and then we do have to go ahead and clean our bore. But we're going to have to establish a rhythm and a way of getting your bore seasoned again, back up to that point where we reach equilibrium, to where we're on with our ballistics tables. And that's going to be very important to figure out how to do if you want to shoot real tiny targets. Now, if you guys are shooting elk at 1,000 yards, you got a 24-inch target, this is not going to be as much of an issue, but it's still going to throw you off enough to notice. You're not going to hit exactly where your point of aim was, and this will throw it off. So this is something that you do want to be aware of for sure. And the same is true with your propellant residue. I don't want to get into the chemistry. I did get into the chemistry during the chemical erosion part in a lot more detail. So if you don't believe me, go ahead and watch that, or you can read the research papers on this. But the modern chemistry of the smokeless gunpowder we have nowadays is very, very clean. And unless you're in a real corrosive environment, like a saltwater environment or something like that, or if you're in a real humid environment and you plan to store the rifle for a long time, you do want to do your cleaning and even probably use oil to preserve your bore while the rifle's being stored over time. But when you're deploying in the field, you don't want to go to town on your rifle trying to remove all your propellant residue, because basically what you have is you're going to have a certain amount of propellant residue deposited in the bore. After a certain point of equilibrium, just like it was with our coppering, your bullet's going to be pushing out just as much. Your bullet's going to start to clean the excessive propellant residue out of the bore. It'll still deposit some behind it, but the next round will clean that out, and it'll be equilibrium. So it'll kind of stabilize, and that's what we're looking for if we want that consistency. And we'll talk more in detail about exactly how to quantify all these things and give you like a number of rounds and how to figure that out. Okay. But that's incredibly important to understand, that there's an equilibrium point for both the coppering and the propellant residues. And the other thing to take away from this, and I said it several times already, but I'll say it again, is that your coppering is not really a problem. If that's sitting in your bore, it's not hurting anything. Copper fouling in your bore is not going to hurt anything sitting there. And with modern powders, propellant residue in normal environments should not hurt anything either. Unless it's, like I said, a real corrosive environment, salt water, or real humid, then you'll probably want to clean it out if you're going to store it for a while. But modern-day propellant residues actually very, very clean, and they don't really pose the same problems that you might have been taught that they pose. Like I said before, most of the articles and most of the different things that you're going to hear about bore maintenance are going to be rooted in ideas that were basically developed when powder residue was a problem, when it was very corrosive. But it's not that problematic nowadays. Unless you're shooting corrosive ammo. If you're shooting an old Mosin Nagant with military ammo or something like that, then this does not apply. You have to clean it every time, just like they say in the field manuals. If you're shooting old World War II surplus 30-06 ammo or 8mm Mauser or something like that, you better clean that sucker as soon as you get it home, and you better clean it pretty good. But I'm talking about modern ammunition here. I should probably highlight that, okay? There's another thing we want to talk about here real quick, and that's barrel conditioning. And that's basically we have the temperature of the bore has kind of a direct bearing on the developed muzzle velocity as well. And different metals have different properties at different temperatures, obviously. They expand at different rates. They become softer or harder, or the lubricity of the metals increases or decreases based on temperature. And so this is something you want to be aware of as well. And I just throw this in here. It's not a whole lot we can do about it besides just be aware of it. And then we can plot this out when we're recording all our muzzle velocity data. But it is something that can throw you off as well. But a cold bore offers more of a resistance to projectile movement and is less susceptible to coppering, even at higher velocities. So in general, cold rifle bores and warm rifle bores are going to have different resistances to the projectile movement. And a lot of that has to do with the engraving resistance pressure. When we're talking about that bullet getting into the rifling, right as it goes through that forcing cone, it's actually going to take up about 2% of the total propellant energy just to overcome that engraving resistance. So it's a significant amount of the power that's that's expended in there is going to be going just to engrave it. And it's going to be easier or tougher to engrave that bullet based on the temperature of both the projectile and the bore. And so all these things have a bearing on what's going on. And so the thing to take home there is basically the temperature of a barrel affects the muzzle velocity and the point of impact due to bore shifts as well. So it's just something that you do want to probably log or be aware of in case weird things happen. When we're doing our problem shooting video, maybe we'll run across some of this and we'll explain it. Because sometimes you have everything that you can think of scientifically accounted for, you still miss for some reason. You can't figure out why. And these are the kind of things that you want to be aware of so that you can come up with a solution for that and correct it, rather than trying to offset by adjusting for something that wasn't the problem, and then your whole set of data is off, and then you really got problems. That can happen too. Okay, so that video wasn't near as technical or as difficult as the bore erosion mechanisms one. There's no need for me to be redundant on all the chemistry. So if you're curious on the chemistry we're referring to there, just go back to the other videos on the chemical bore erosion and the thermal and mechanical processes, because we're going to be referring back to that as we continue here. So the next video I'm going to talk about is the long-range rifle cleaning regime and how to establish that. How are we going to clean these rifles to keep the bore condition as consistent as we can without hurting the bore? And that's the thing. We don't want rust to happen. We want to make sure that our rifle bore is clean enough to prevent it from having problems, but we don't want to change it too much to where it's going to be impossible to basically correct for all these different changes in bore friction. So how do we accomplish that? Stay tuned and we'll find out pretty soon here.